Okay, so let's get started. We're going to be taking a look at working with gear detection setup within our Link G5 and G4X programming. Now this tutorial is going to be focusing on just our basic gear detection procedure. So how do we define the gear in the Link using just vehicle speed and engine RPM? We have a lookup table that we can define. It's a very straightforward process. We're going to learn how we can set up a speed sensor source real quick here in the beginning of the tutorial, and then demonstrate going through setting up our gear detection chart. Now we do have other ways that we can detect gear with the Link, such as using a gear position sensor. This is found on a sequential transmission. We're not going to go over that here in this training module. This is really just sticking to more of the basics. We will have a dedicated training tutorial talking about setting up gear detection and setting up all the additional things for a sequential transmission. There's a lot to unpack there. We're going to keep that topic for another tutorial. Let's jump in and take a look at where we can set up our gear detection and vehicle speed sensor setup. We actually had another tutorial setting up wheel speed sensors and vehicle speed sensors, so we're going to revisit just some of that here in the beginning of this training module. We're going to move from our basics page and go over here into our VSS gear page. And here, this is where we define our gear detection. We can see it in our window right here. There's a gear ratio table that we're going to be working with in this training module, but first we have to set up a speed source specifically for our driving wheels. So the driving wheels would be the wheels that are powered from the drivetrain. So we have two different terminologies of the Link. We have our driving wheels and we have our driven wheels. Driven wheels would be wheels that aren't powered from the drivetrain. So for example, front wheel drive car would be driving wheels in the front, driven wheels in the back. If we're doing rear wheel drive, we would have driven wheels in the front, driving wheels in the back. The Link needs to see a driving wheel speed source in order to use the speed reading to calculate a gear detection feature. Let's go and take a look at this. So we're going to first go into our general purpose speed. I'm going to go set up a transmission speed sensor for a front wheel drive transaxle. It's a Hall effect style sensor, so we can use that for our driving wheel speed source so we can calculate the gear from that. We're going to go here to our label, and I'm going to go ahead and label this, we'll just call this VSS speed, vehicle speed sensor speed. And then we're going to go to our source, and this is where we've wired in the signal from our speed sensor. The speed sensor I'm working with here is a 3-wire sensor. It's a Hall effect sensor, so power, ground, signal. Signal comes back into the Link. It's a 0 to 5 volt pulse on a Hall effect sensor. We're going to go ahead and set this to our digital input too. That's where I've wired that signal into for the Link G5. Let's go ahead and click that. Now we have our pull-up resistor activation edge, and we have our frequency filter. These need to be defined in order to tell the Link what kind of sensor we're working with, essentially. We're dealing with a Hall effect sensor, that 0 to 5 volt pulse style. It'll have a pull-up resistor on to complete the circuit. If we're dealing with a reluctor sensor, typically that's a 2-wire sensor, we're going to be having no pull-up resistor on. The next is going to be the activation edge. If we're dealing with a Hall effect sensor, we'll be using falling as our option. Although you can use rising, it doesn't really matter. It's not going to change much when we're talking about Hall effect. When we're talking about a reluctor, it is important that's going to be counting the correct edge on the sinusoidal wave. If what we're looking for on a scope when we're looking at a VR sensor is where, looking at the coming up and down in the actual waveform, where we have the fastest rise or fall in the signal, which will designate in that sinusoidal wave if it's a rising or falling. We talked about how to determine that in the cam and crank tutorial, so you can go back and take a look at some more specifics with setting up a reluctor sensor. I'll keep it simple for right now. I don't need to worry about that. I have a Hall effect sensor, so I'll be going setting this up on falling and clicking OK. The frequency filter here is typically used for a reluctor sensor, but sometimes found a need on a Hall effect sensor. This will allow us to provide a filter for working with that sensor input. So if we're noticing the sensor's kind of glitching around a little bit, it's not smooth in its reading, we might have to apply a filter here. We want to apply the lowest filter level possible for the sensor, so there's a reduced latency or reading from the sensor as we're working with this for the speed detection. I'll leave it on none for right now. Typically, we don't need it for a Hall effect. They usually produce a nice clean waveform. The next thing is our calibration number. The calibration number needs to be set up based around you actually driving the vehicle and looking at a GPS speed. You can add a GPS app to your phone, drive the vehicle at a known speed, let's say 40 or 50 miles per hour, for example. Drive it consistent, let's say on the highway. You can go in here to the calibration number and then set that so that your driving wheel speed matches your GPS. We do have to go in here for the driving wheel speed source, double click, and set it to our general purpose speed, assuming we're using this as a transmission speed. for our speed source for the driving wheel. If you're using wheel speeds, you'll assign it to the wheel speed that you're using. I'll go ahead and just do GP speed 1 since we're using our transmission speed. Now what we can find, taking a look at this, as I'm driving, let's just say, hypothetically here, I'm going 50 mile per hour. My GPS is showing 50. I'm steady state cruising. The driving wheel speed sensor is showing 31.8. What we're going to have to do here is change our calibration number so that the wheel speed sensor, the driving wheel speed value here, matches the GPS. So I'll go ahead and change it to a value of 100. Obviously that changes it a lot. Let's go ahead and change that to a value here of 50. See what that's going to do. Okay, that's making it worse. Let's go here. Let's put it to a value of 300, a little bit better. Let's try 320. It's getting lower, so we're gonna have to kind of just go back and forth here. There's 250, there's 230.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.